NASA's Moon Rover plans have changed recently. Originally, the agency intended to pick one single, very expensive gold-plated rover. Now, it has pivoted to selecting multiple, simpler and less capable rovers for Phase 1 of its moon base concept. This approach allows for a range of different rover designs and removes the risk of relying on just one company. In this video, I'll walk through NASA's new strategy for lunar mobility, including the procurement plan and the phased approach. I'll also highlight a weakness I see in NASA's overall moon plans and finish with my thoughts. After watching, please drop your thoughts and opinions in the comments below. We can discuss this topic and others during the live stream I host every weekend. Why NASA needs moon rovers? Astronauts walking on the moon's surface can't travel very far, at most around 2 kilometers per day. With a rover, that range can increase to 10 kilometers or more. This dramatically expands the area they can explore, boosting the scientific return and improving the chances of finding suitable sites for future habitats or landings. NASA is specifying that these rovers must reach a maximum speed of 10 kilometers per hour, weigh no more than 500 kilos, handle slopes of up to 20 degrees, and survive for 150 hours in darkness. NASA LTV Procurements. NASA has asked commercial LTV vendors to provide simplified variants of both crewed and uncrewed rovers. The agency also plans to bring additional vendors on board for Phase 2 LTVs starting in 2027. Phase 2 covers the period from 2029 to 2033. NASA expects to run competitions every 18 to 24 months for future rover deliveries as the moon base capabilities evolve. NASA's mobility needs Phases 1, 2 and 3. From the mobility slide shared at the Ignition event, we can see NASA's evolving needs for lunar mobility across the 3 phases of building a moon base. In Phase 1, which runs until 2028, NASA needs simpler rovers with a 1-year design life. Although the crewed versions will be simplified, they must still support autonomous operations. The agency expects these rovers to be used for site surveying, site preparation demonstrations, and logistics. In Phase 2, 2028 to 2033, NASA anticipates a significant increase in both crewed and uncrewed rovers. More logistics and science payloads will need transporting across the lunar surface, along with the first demonstrations of lunar soil manipulation. During both Phase 1 and Phase 2, NASA will be the sole user of these lunar rovers. Previously, the agency had planned to allow commercial use of the rovers when NASA wasn't using them. This would have helped LTV vendors by letting them sell mobility services to lunar startups or other space agencies. Now, lunar operators will either need to negotiate occasional access with NASA or deploy and pay for their own rovers. In Phase 2, NASA will use the rovers for science operations, initial logistics transport, and possibly power cable deployment as the lunar power grid begins to take shape. In Phase 3, from 2033 onwards, the rovers will finally be opened up to commercial users. At this stage, NASA expects a 10-year design life, full logistics transfer capabilities, including a robotic arm, and the ability to operate in permanently shadowed regions such as Shackleton Crater. These areas are likely to contain water ice, but they remain in constant darkness and are extremely cold. In fact, the crater floor is colder than the surface of Pluto. To meet these demands, nuclear heating via radioisotope heater units will almost certainly be required. NASA plans to land 7 rovers in Phase 2 and an additional 4 in Phase 3. Landed payload mass will rise from 60,000 kilos in Phase 2 to more than 150,000 kilos in Phase 3. The nuclear reactor for the Artemis base camp is expected to arrive in Phase 3, which will require the most capable rovers to transport it safely to the right location. The site will need prior preparation, most likely with protective berms to contain any potential radiation leak and protect nearby surface assets. The Contenders. In April 2024, NASA selected 3 vendors to provide lunar rover vehicles: Lunar Outpost, Intuitive Machines, and Astrolab. The total funding for the LTV contract was $4.6 billion. All three commercial LTVs are well into testing and have been validated by NASA, including by its astronauts. These rovers were originally developed for NASA's more ambitious design, a highly capable vehicle with a robotic arm and a 10-year lifespan. It's likely the vendors will now descope their vehicles to deliver simpler, lower-mass versions for Phase 1 missions. Lunar Outpost has already announced its descoped vehicle. Lunar Outpost developed a crewed lunar rover called Eagle. It's a highly capable rover that can operate autonomously and is well suited for commercial use, thanks to its reconfigurable cargo bed and robotic arm for swapping payloads. The rover can also operate through the lunar night. Following NASA's reduced requirements for Phase 1 LTVs, Lunar Outpost was the first to respond with its new Pegasus vehicle. As we can see in the video, Pegasus is smaller and simpler, and it should comfortably meet NASA's less demanding Phase 1 requirements. Intuitive Machines is best known for its lunar landers, but it has also been developing a rover called MoonRACER. This LTV is large, roughly the size of a pickup truck. It can carry 2 fully suited astronauts and up to 400 kilos of cargo, while towing an additional 800 kilos with a trailer. It has a top speed of 15 kilometers per hour and can handle 20-degree slopes. Unlike the other two contenders, Intuitive Machines can land its rover using its own Nova D lunar lander. However, the company's 2 previous missions with a smaller Nova C lander both ended in tip-overs, and it has yet to achieve a successful lunar landing. In late 2025, Intuitive Machines demonstrated high-power wireless power beaming to its MoonRACER rover in partnership with Starcatcher, a company developing solar power beaming satellites. Beamed power from orbit could allow rovers to operate inside lunar craters or during the lunar night. It would also reduce the need for large batteries on the rover itself, lowering overall vehicle mass. The first power beaming satellites are due to launch later this year, although they will initially operate in low Earth orbit. Intuitive Machines has a concrete, demonstrated capability here that could interest NASA. It remains to be seen if Starcatcher has any interest in lunar power beaming. Another startup, Volta Space, has plans to build a constellation of lunar power beaming satellites. These would provide power to lunar assets using only a small light port receiver. The next Blue Ghost lunar lander mission from Firefly Aerospace already carries one. These power beaming solutions address the biggest challenge in lunar exploration and development, surviving the lunar night. As highlighted in NASA's newly published 2026 Civil Space Shortfall List, one of the top challenges for companies is operating for extended periods on the lunar surface. A lunar economy cannot function if it only works half the time. Interestingly, NASA's second biggest challenge is surface mobility and logistics, exactly what lunar rovers are designed to solve. And finally, Astrolab. Astrolab claims its Flex lunar rover will be the largest and most capable ever to operate on the moon. It offers a maximum cargo capacity of 1,600 kilos and a volume of 3 cubic meters. One standout feature is its hyper-deformable wheels, developed by Venturi. The outer rim includes springs that allow the wheel to deform by up to 60 millimeters. That's about 2 inches. This gives exceptional traction on the lunar surface, and Astrolab says the rover can handle the required 20-degree slopes. NASA's exclusive access to rovers, phases 1 and 2. Unfortunately, NASA requires exclusive access to the rovers during both phase 1 and 2. This prevents lunar startups from using them. Any lunar operator that needs a rover will therefore have to pay for their own launch or wait until phase 3, when the rovers are finally opened up to commercial users. That said, Astroport and other lunar startups require specialized equipment for excavating regolith, so they likely couldn't have used a standard rover anyway. Interloon, the helium-3 mining startup, is working with Vermeer on a specialized lunar vehicle designed to drill and excavate 100 tons of regolith per hour. As a result, it will not be directly impacted by NASA's decision. What's missing on lunar mobility? I don't see much emphasis on lunar infrastructure, such as roads, landing pads, and protective berms. Roads in particular would allow much faster travel and directly support site exploration, surveying, and science on the moon. Lunar startups like Ethos Space Resources, Astroport, and others are already working on lunar infrastructure, yet I don't hear much from NASA on this subject. It's strange that NASA places such strong emphasis on mobility, but shows little interest in large-scale infrastructure projects like lunar roads and landing pads. Roads would enable faster and safer travel, especially in the moon's low-traction environment. The first mention of infrastructure appears in Phase 2, where NASA includes a section on landing and habitat site preparation. The NASA Moon Base Architecture Guide only discusses large-scale excavation and preparation capabilities in Phase 3. Perhaps NASA expects lunar infrastructure to be delivered entirely by the private sector. The agency does fund some of the necessary technology through small business grants. It's likely that small-scale technology demonstrations will fly on future lunar lander missions, especially with the increased cadence of landings now planned. The new Phase 1 LTVs are lightweight, which will make maintaining traction on the surface more difficult due to the moon's gravity being only 1/6 of Earth's. It's hard to see how these Phase 1 rovers could perform any significant excavation work. The physics of moving lunar regolith requires sufficient countermass to prevent the excavator from tipping over. Space startups such as Redwire, Ethos Space Resources, Astroport, Lunar Outpost, and Astrolab are all actively working on or supporting lunar infrastructure development. Perhaps the upcoming NASA event later this week on the moon base will provide more detail on lunar development plans. Personally, I see the lack of support for lunar infrastructure as a weak link in NASA's current approach. Final thoughts. NASA's new approach to LTVs should get lunar rovers onto the moon sooner and at a lower cost. Over time, the capabilities of these rovers can be upgraded, eventually enabling operations inside permanently shadowed craters that are likely to contain significant amounts of water ice. What do you think of NASA's new approach to buying lunar rovers? Does exclusive access for NASA in Phases 1 and 2 undermine lunar startups? Leave your thoughts and opinions in the comments section below. Thanks for watching. If you enjoyed this space video, consider buying me a coffee to help fund more episodes like this. The link is in the description. Watch the weekly live stream to see the images, clips, and slides from this week's videos. It's a live Q&A on this week's space topics, where I read out some of the best comments. The more people join, the more fun the live stream is. Be sure to like and subscribe so you'll see our upcoming videos. We make videos every week covering the space industry with an emphasis on the smaller space startups that aren't covered so well on other channels. See you soon.